Now, how did this apply for Kruskal's algorithm? For Kruskal's algorithm, we said this edge E star was between vertices V and W. We added this edge E star if the component containing V, one of the endpoints, was not the same as the component containing W. So V and W were not connected in the current subgraph. So what was the set S in this example? The set S in this example was the component containing V or the component containing W. Let's just say the S was the component containing V. And therefore, since the component is a maximal set of connected vertices, we know that there's no edge in the partial solution which crosses from S to S bar. And then, since we consider the edges in increasing order, in sorted order, then we know that E star must be the minimum weight edge crossing from this component to outside. So this edge E star that Kruskal's algorithm considers satisfies the hypotheses of the lemma. So if we add an E star to our partial solution, we'll still be on our way to an MST. So this proves correctness of Kruskal's algorithm. So Kruskal's algorithm uses a particular type of set S, but this is true in general for any cut S. Now it's important to understand the statement of the cut property and also to understand the proof. The statement, the main idea is that any edge which is minimum weight across a cut is going to be part of some MST. Why? Because if you give me a tree T which does not contain this minimum weight edge across a cut, then I can add this edge into the current tree and I can construct a new tree which is of smaller weight. Actually, to be precise, I'm not necessarily going to construct a new tree with smaller weight, but if you give me a tree T which does not contain this edge E star, I'll construct a new tree T prime where the weight of T prime is at most the weight of T. So the weight doesn't increase. And that's going to be the intuition for the proof. We're going to take this tree T. We don't know this tree T, but we know there exists an MST T which contains X, our partial solution so far. And now we're going to add this edge E star into X. Now if this MST T contains X union E star, then we're all done. Now there's no reason why this edge E star has to be in this tree T. So what happens if edge E star is not in the tree T? Well, then we're going to construct a new tree T prime where the weight of T prime is at most the weight of T. And in this tree T prime will be the edge E star and also X. And we'll construct this tree T prime by modifying the tree T slightly, by adding in the edge E star and then removing an edge in order to construct a new tree. So let's go ahead and dive into the proof of the cut property.